Hello everyone, this is Alistair here, and today's problem of the day is titled Bitwise AND of the array. So let's have a look at the problem itself. So in this problem you are given an array of n integers and an integer x, and in one operation they have given that in one operation you can change the ith element, that is any element of the array A, to any integer value where I is specifically in between 1 and n, and we have to calculate the minimum number of such operations required such that bitwise AND of all the elements of the array is strictly greater than x. So in this particular example you have the elements 3, 1, 2 and 7, and they have performed or modified the array such that it has the value 3 as it is, but 1 has been changed to 3, 2 has been changed to 11, and 7 is as it is. So after performing bitwise AND on all these elements, you get the value 3, which is strictly greater than 2 over here. And in the second example, n is 3 and x is 1, and you have the array elements 2, 2, 2. So if you perform bitwise AND on all these elements, you get the result to be 2, which is strictly greater than 1. That is why the number of operations that one needs to perform in this case is 0. So let's have a look as to how we'll approach the problem. So let's first consider all the array elements, that is for the first example, that is 3, 1, 2 and 7. So let's write it down. We have our array A, it has the values 3, 1, 2 and 7, and we also have x to have the value 3, to have the value 2, and also let's write down the corresponding binary number representation for the array elements. So 3 can be written as 0, 1, 1, 1 can be written as 0, 0, 1, 2 can be written as 0, 1, 0, 7 can be written as 1, 1, 1, and also 2 here can be written as 0, 1, 0. So in order to go over the problem, what we'll do is we'll create a variable called mask, and we'll first have a look at the algorithm itself, then try to explain why exactly we are doing that. So we'll create a variable called mask, and since we have to calculate this particular AND operation and its value needs to be greater than 2, the only possible way of doing that is by considering all the left bits, that is the bits to the left side of x, to have the value to be set. So for example, the fourth bit of x is set, and if we set that fourth bit for all the elements of our array A, and if we perform AND operation, then its value, it would surely be greater than x. So in order to go about this, we'll consider any arbitrary bit position. Let's say since int is represented by 32 bits, we'll start from 32. That is, we'll let our mask value have its 32nd bit to be set. So let's say its 32nd bit is set. Now what we'll do is simultaneously we'll check if its 32nd bit is also set for x or not. Since the 32nd bit for x is not set, meaning we will not get the same value as x, because if that is the case, let's say for example this particular x value had the second bit set and also the 32nd bit set. In that case, if I modify all the values to have this 32nd bit set for all the array elements, then its value would not be greater than x, because we still have our second bit to be considered. That is why every time we are setting a bit for our mask variable, we will be checking if that particular bit is also set for x or not. And since it is not set in this case, we'll simply compare this mask, perform AND operation with each of the elements of our array A, and check if the AND operation results in the mask itself. So we'll perform this particular mask variable with its 32nd bit set and perform AND with 3, which is nothing but 0, 1, 1, and this would give me 0 value, which is not equal to my mask. This simply means that I would have to change this particular number, and that change will increment it by 1. So if for the 32nd bit set for a mask variable, I'll have the count 1, meaning that one of the elements of my array needs to be changed. Then again I'll consider this particular bit, that this particular element, that is 1. I'll write down the 32nd bit as it is. I'll consider 1, that is 0 0 1. On performing AND, I get the value 0 again, meaning it is not equal to our mask, which means that I would have to change this 1 as well. So on changing, it simply means that our number of operations would get increased. That is we have to change two elements of our array. Now again considering 2, for the mask value with the 32nd bit set, we'll AND it with 2, we'll again get 0, and we'll increment the count to be 3. That is 3 numbers have to be changed. Similarly for 7, I'll AND it with the binary value for 7, and then on ANDing I get 0 as the result, which means that 4 elements of the array needs to be changed. Now we'll keep on doing this for every bit, and we'll do this till any one of the bits becomes equal to the set bit for x. So let's take another bit value. Let's say for example we did this operation and reached the 4th bit, that is our 4th bit is set. So 4th bit in this case would be lying here somewhere in case of x. So 4th bit is set. Now we'll perform the AND operation of this mask with its 4th bit set with each of the array elements again. So I'll AND this 1 0 0 with 3, that is 0 0 1 1, and I'll get the value 0, meaning it is not equal to my mask, which simply in turn means that I would have to change this element. So our number of change would be incremented by 1, which was 0 initially, so it would be 1. Now we'll consider the next element which has the value 1, and I'll AND it with our mask, and I'll get the value 0. Since it is 0 and not equal to our mask itself, we'll increment our count to be 2. Again I'll do the same for the remaining elements, and again I get the value to be 0, which means it is not equal to my mask. I'll increment my count. Similarly for the number 7, I get 0, I'll increment my count. So the number of operations that I have to perform when my 4th bit is set for the mask is 4. Now let's move on to the next bit that would be set. Let's first erase this. Now let's say my 3rd bit is set. Now if you look closely, since my 3rd bit is set, this 3rd bit, let's say for example my 2nd bit is set, not 3rd. So let's say my 2nd bit is set, but if you look closely, this 2nd bit is also set for x. Since this is the case, we will not be considering this particular mask. We'll simply remember this mask and consider the next bit that we have to set. So that would be for the first bit. So in this case our first bit would be set, but since we have remembered the mask, our mask value would be 0 1 1. This is because this particular bit was set for x as well. So we'll remember that, and we'll simply consider the next bit and set it to 1. Now we'll perform the same AND operation with each of the individual elements. Now on ANDing this mask with 3, I get my value to be 3 itself. Since this value is equal to my mask, it means that I need not change this particular element. So my count would be 0 itself. I'll consider the next element. AND it with my mask. So the next element is 001, and on ANDing this I get the value 001, which is not equal to my mask, meaning this value, this element that is 1 needs to be changed. So my count would become 1. Now next up I'll consider 2, AND it with my mask again, and again I can see that I get a value with the binary 010, and it is not equal to my mask. So I'll keep the count as it is. I'll increment the count, and my count will become 2 now. Now I'll consider the last element, and I'll AND it with a mask. So the value I'll receive is 011, which is equal to my mask. This means that this particular element, that is 7, need not be changed. So my count will remain as it is and will not get incremented. So in this case, if I consider this particular mask, the minimum number of changes that I have to do is 2. And since I've reached the end of the number of bits that I can change, since I've reached the first bit and there are no other further bits that I have to change, I'll end the operation and I'll simply return the minimum possible operation. So here in this case, for example, our result would be 2. So let's jump right onto the code and have a look as to how we'll go about the problem and code it. So let's create a variable called answer. Now if you look closely, that the minimum number of operations that you can perform, such that on performing AND h value is greater than 2, is n itself. Since there are no elements greater than n, we'll initialize our answer with n itself, and we'll create our mask integer, and let's say it has the value 0. Now we'll loop over our uh, individual bits, that is, we'll start from the bit let's say 32, and we'll continue till we reach the 0th bit. Let's say we start with 31 and we continue till 0th bit, and we'll keep on decrementing our I value. Now first we have to check if this particular bit, that is the 31st bit, is set for the variable x or not. If that is the case, then we have to remember that bit, right? So what I'll do in that case is that I'll consider my variable x. I'll I'll right shift that variable, and I'll right shift to the position I, and I'll AND this particular variable that will result as an operation that is x right shift I, and I'll AND it with I itself. Sorry, not I, but 1 itself. This would give me the set position for x. For example, if 31st bit was set, then we'll check if the 31st bit for x also is set or not. And we can do this by shifting that 31st bit to the 0th position, and then simply ANDing it with 1. So if I AND it with 1 and if I get the result to be 1, it means that the 31st bit for x is set. So if that is the case, I'll remember the mask and I'll set the bit that is set for x as well. So my mask would be modified to the value which has its bit set. So it would be 31st bit if that is the case. So after doing that, we simply need to continue since we won't be considering that particular mask. Now for example, if that particular bit is not set, let's say in our case, for example, our third bit was not set. So for that case, I'll simply create another variable, consider the mask again, and I'll OR it with that particular bit. But we would not be storing this temp for upcoming iterations, we will be simply reassigning it. So on performing this operation, we'll get the temp to have value. For example, in this case, we had our mask to have the value 010, since the second bit was also set for x, and in the next iteration we were setting this to 1. So our mask resulted in 011, which is stored in this temp variable for now. So after storing this, we'll create another variable, let's say count, and we'll initialize it to 0. Now we'll loop over all our array elements. Let's say we loop over using the variable j, and for every element, we'll add that particular element with our temp variable, that is this mask 011, and we'll check if that AND operation results in temp itself. Yeah. So if that is the case, then we simply have to increment our count. So as we have discussed earlier, if ANDing the mask value with, let's say for in this case where the array element is 7, if I AND this value with 7, I get the mask itself. So mask here in this case is the variable temp. So I AND temp with 7, I get temp itself. If that is the case, then we'll not be incrementing the count. But if that is not the case, which is in case of 2 over here, since we did not get the same result as our mask, we had incremented our count. So we are doing the same over here. And after doing this, we'll store our answer variable to have the minimum value between our answer itself and our count variable. Now we'll simply return the answer. Alright, so that was it for today's video. If you have any doubts or suggestions, you can put them down in the comment section, and thanks for watching.